Hi everyone. I would like to discuss the basic use of R in the next few videos. So you can see the statistics 50-30 slides for details. If you have already studied R, then you can skip these videos and you can go to quizzes. Okay, so I use the R screen, R console to show some examples. Okay, so the first basic operations can be done just as usual calculator, 1 + 1, addition or subtraction, division or multiplication and division, and also some combination such as the 1/4 minus maybe 3/4. And some other things such as the power function, 2 cube is the 2 hat 3. And square root, you can do this, or square root can be done by using 2 to the power 0.5 or maybe 2 to the power 1/2. Absolute value is by function ABS. And exponential function, e to the power 2, e is about 2.7, so the square is 7.38. And so on, the logarithm. So we have many ready-made functions. So if you search on the internet, you can find most functions. Yeah, and also R can assign some sequence of letters to some number. For example, if you want to define x as 2, then you can define in this way or this way. So this is the, double equal is different. So the first two are used to define x is equal to 2. Okay, so if you define y, then you can calculate x plus y or x times y, and so on. And R can use also the vectors. So this is a convenient feature. So if you define x as 1, 2, 4, 8, 16, x is a vector. So it includes 5 numbers. So you can extract, for example, the third element of x in this way, or 2 to 5th element in this way, or maybe the first and the 5th element by this way. Here, the C parenthesis declares a vector. So if you just declare a scalar, it's just fine. So you can define the x equals 2 or x arrow, the left arrow 2. But if you want to define a vector, you have to use this format, the C parenthesis, and separated by commas. Okay, so some functions work on a vector, for example, summation or average, mean or median, standard deviation, and so on, variance. And some vectors can be made without specifying all elements. For example, the sequence from 1 to 10 can be generated by just 1 colon 10. So this colon includes the declaring a vector. So this is vector. If you want to have increment of 2, then you can do this way. And some other functions such as sequence, maybe sequence the 1 to 9 by 2, then 1, 3, 5, 7, 9, or repeat 1 to 10, 2, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we repeat this again. So a vector with 20 elements. So you can do, you can use these things to deal with the vectors. And vectors also, you can do operations. If x is equal to 1, 2, 3, and y is maybe 2, 4, 6, you can define the component-wise summation. So 1 plus 2, and 2 plus 3, 4, and 3 plus 6 are 3, 6, 9. And the multiplication is also component-wise. So x is 1, 2, 3, y is 2, 4, 6. So 1 times 2 is 2, 2 times 4 is 8, and 3 times 6 is 18. So it works in this way. X divided by y, x minus y work in the same way. Okay, so some other functions are in R to deal with the two vectors. So in statistics, the relationship between two vectors are important. For example, the x is the weight of mice, and the y is the height of mice, and we want to see relationship between x and y. Okay, so next example, this is the midterm 1 score for 5 students and midterm 2 scores for 5 students. Suppose the 5 students, A, B, C, D, E, the scores are 10, 50, 70, 90, 90, 30. And midterm 2 score is the 20, 80, 100, 60, and 40. Okay. So the first element of midterm mid1 vector and the first element of mid2 vector are for the same student. And you can see, so these are positively correlated. Mid1 score is higher, then midterm 2 score is likely to be higher. For example, 10, 20. So both low scores, and 70 and 100, both high scores. So you can use the correlation function to calculate correlation coefficient. Okay. So so this is the way to calculate correlation coefficient. Okay, so next we would like to discuss the statistical procedures. As an example, we discuss paired t-test. So remember that we have two vectors, the midterm 1 and the midterm 2. And it sounds that the midterm 2 scores are higher than midterm 1. Actually, the 4 out of 5 students have higher score in midterm 2. 10 to 20, 50 to 80, 70 to 100. Only the 4 students get lower score in midterm 2. So we would like to test if midterm 2 is significantly higher than midterm 1. So we can use the t.test function. This is the t-test function to see if the difference is significant. So if you type t.test midterm 2 minus midterm 1, okay, so this vector is this, so 10, 30, 30, negative 30, 10. So if you test this, this is the output. Okay, so t value is 0.91, degrees of freedom 4 is 4, and the p value is 0.413. So p value is not less than 0.05. So at 5% significance level, we cannot reject the hypothesis that midterm 2 is significantly different from midterm 1 scores. So with these only 5 observations, we cannot have a solid conclusion whether midterm 2 is more difficult or easier than midterm 1.